All right, so section 2 of chapter 9, we're going to talk about angle measurements and radian measures. God bless you. It might be new to some of you guys. When we talk about angles themselves, okay, you guys are all familiar with an angle, but we're going to be talking about angles in regards to a coordinate plane, an XY chart, right? So when we talk about this, we're going to use some vocabulary words here. You are always beginning, every time you draw an angle, when you're saying, okay, this angle is 75 degrees, this angle is 125 degrees, you're always beginning on the positive side of the x-axis. You're always starting at 0. That's called the initial side. Why is it called the initial side? What does initial mean? The first, where your angle starts. Where your angle ends is called the terminal side, because if your job is terminated, then your job is over. Does that make sense? Okay. Is everyone familiar with this is 0 here, and then up here is 90. This is 180. I know it's already written there. I'm just going over it. This is 270, and then this is also 0 is the same as what? 360. There's 360 degrees in a circle. If we're talking about quadrants, this is quadrant 1, this is quadrant 2, this is 3, and this is quadrant 4. Let's talk about the signs in the quadrant. What are the signs of X and Y in quadrant 1? They're both what? Positive. This is plus, plus. Good. In quadrant 2, X is negative, Y is positive. In quadrant 3, everything's what? Negative, negative, good. And in quadrant 4, X is positive and Y is negative. Those are going to be really helpful things to know. So when you are asked to draw an angle in standard position, okay, that means you start at the positive side of the x-axis. If it is a positive angle, you go in the upwards direction. That's our positive angle measures. If it's negative, what direction do you go? Opposite, you go down. So if it's negative, that's our negative angle. How many degrees are in one whole circle? 360. So if it's bigger than 360, you're going to go around and then a little bit, okay? So the first thing we're going to talk about is how to draw angles in standard position. I'm going to show you what I think is the easiest way to do it, easiest way to look at it. It's up to you guys. But if I look at this first one, it says 240. Okay, so the first thing I'm going to do is I'm going to draw my X and Y, and I'm going to write 0, 360. Is this a positive 240 they want me to go, or a negative? Positive. So I have 360, this is 90, 180, 270. Everybody with me? So before you start drawing and think about all this stuff, where is 240? It's in between which two numbers? 270 and 180, right? So all you have to do is your angle begins right here on this initial side, and it's a positive. Positive means we're going to be going in which direction? Up. So I'm going to go up, I'm going to bring it over here. It doesn't matter exactly where you end up, it just has to be in the correct quadrant. It has to be in between. Like you guys just told me 240 is in between 180 and 270, so it's got to be there. What quadrant is that, guys? This is quadrant 3. Good. Questions? Pretty basic from when you're drawing, okay? Here we go. 500. Positive or negative? Positive. So I have at 0, 360 here. This is 90, 180, 270. If it's positive, I start on my initial side and go which direction, up or down? Up. Now, guys, let's think about this for a second. 500 is bigger than what? 360. So I'm going to go over here and I'm going to say, okay, I need to know, I'm going to go around one whole circle, I know. So I'm going to subtract 360 degrees. So what's 50 minus 36? 14? 140? Okay. So think about where 140 would be. 140 is in between where? 90 and 180. So you're going to start here at 0. You're going to go one whole circle. Whoa, that's a horrible circle. You're going to go one whole circle around, right? There's your 360. And then where are we going to continue to go to? Over here. In between 90 and 180. Because it's not 140 degrees. It's 140 plus 360. It's 500. Those are called coterminal angles. We'll talk about that in 1 second. But if you have something that's bigger or smaller than 360, you're going to go one whole way around. So let's look at C. What kind of an angle is C? It's negative. Why do I keep asking you guys that question when we start off here? Because negative goes in which direction? Opposite. So guys, this is negative 90 down here. This is negative 180. This is negative 270. Goes opposite. If you have a negative angle, which way do you go, up or down? So where would negative 50 be? Between 0 and negative 90. Good, so it's going to be here-ish. And what quadrant is that? Quadrant 4. Good, very good. Does that make sense? A little bit. Look, it's like art class. Isn't that great? All right, moving along. We got some examples here. Okay, let's do this kind of quick. 65. Positive or negative? Positive. So this is 0, 360. 90 is going to be up. 180. 270. Where is 65? In between what and what? 0 and 90. So I start here with the initial, and I go up somewhere in here, and I draw my angle. What quadrant? Quadrant 1. Good. 300. Positive or negative? Positive. Good. So I have 0, 360 here. 90 is up. 180 is to the left. 270 is down. Where is 300? In between 270 and 360. Good. So I'm going to start here at my initial. Since it's positive, I'm going upwards. And I go all the way around, and I stop somewhere in there. Somewhere in quadrant what? Perfect. All right, 3 is a tad different. How is 3 different? It's negative. So I have my 0, negative 360. But which direction am I going, guys? Down. So negative 90, negative 180, negative 2, I'm not sure what that was, 270. In my mind, it looked different. Where is negative 120? What quadrant? Quadrant 3. Good. I'm going to start here on the initial side, and instead of going up, I'm going to go which direction? Down. Perfect. Quadrant 3. What do I know I'm going to have to do in 4? I'm going to have to go one whole circle, right? I'm going to have to go one entire circle. I have negative 450. I'm going to add a circle to it. I'm really subtracting, right? What's 360 and 450? What's the difference between those two? 90, okay. That's called a quadrantal angle. So I'm at 0, negative 360, negative 90, negative 180, negative 270. So I have to go, starting here, and I go one whole circle around, downwards, right? And then I end up where? Where do I stop? Right on the 90. You don't get those a lot, but that's what that looks like. It's called a quadrantal angle. It's not in a quadrant. It's on a quadrant line. Right, let's scoot along here. Finding coterminal. This is really, really, really easy, I promise. Coterminal, coterminal, coterminal. Just a second ago, I said something. I said to you guys, those are the same. It was 140 and 500, I think, right? You had 360, or you had 500, and we took one whole circle away. We got 140. We were in the exact same position. A coterminal angle, like say I have this angle right here. Right? Everybody see this blue angle right there? Would you guys agree with me that if I started on my initial side, and then I went one whole circle around, and then went up a little bit, I created a new angle. It's one whole circle bigger than the one I already drew, but it's on the same spot, right? You can draw an infinite amount of angles in the exact same position. You can just keep adding or subtracting a whole circle. So when they ask you to find coterminal angles, you're going to add and subtract 360 degrees. If they ask you for one negative and one positive, you keep adding till you get a positive. You keep subtracting till you get a negative. It's really, really simple. So I want one positive and one negative coterminal angle with negative 45 degrees. All right, so here's my initial angle, negative 45 degrees. Now, you guys could have all different answers. Some of you will add 360 one time. Some of you will add it 2 times. As long as the difference is 360 degrees, you're good. But if I add 360 to 45 degrees, what do I get? It's the same as saying 360 minus 45, right? It's 315. What kind of an angle is 315? Is that positive or negative? Positive. So there is your positive coterminal. Perfect. Now, how would I get a negative coterminal angle with 45? I would say negative 45 minus 360. In this case, what are you doing to those two numbers? You're adding them. All right, so I'm going to get a negative. Let me write it like this so you can see a little better. What does this equal? 405? Negative 405 degrees. Is it important to have that degree symbol? Yes. How do you find coterminal angles, guys? You add 360 to get a positive. You subtract. If you add 360 and don't get a positive, add another one. Just keep adding and subtracting whole circles. So if I have 395, right? I'm starting off with 395 degrees. I want one positive coterminal, so I could add 360. So if I add 360 to 395, what do I get? 755. What is it? 755. Okay. Is that a positive angle? Yeah. That's fine. Perfect. What about if I want a negative one? Well, take 395 and subtract 360. What do I get? I get 35 degrees. But I'm trying to get a negative one, though. What do you think I do? I'm going to subtract 360 again. Could I use this as my positive coterminal? Yeah. Those two answers are both acceptable. If I asked you for one positive, one negative, if somebody told me 755, that's correct. If somebody told me 35, that's correct. As long as the difference between the two numbers is 360. Now, if I have to get a negative one, then I have to say subtract another 360. So what's 360 minus 35? Come on, guys. Negative 325. Okay, perfect. So negative 325 degrees. Now, what if somebody wanted to be funny and be like, I don't like that one. I'm going to subtract another 360. Fine, do that. To find coterminals, you add and subtract 360 degrees. You just keep adding until you get a positive. You keep subtracting until you get negative. Does that make sense? All right. Oh, goodness. Do we have to go through all these? We'll just do it real quick. 80. We'll do a couple of these. 80 plus 360 and 80 minus 360. It's always the angle first, not the 360. So what's 80 plus 360? What is it? 440 degrees. Perfect. What's 80 minus 360? Negative 280? Are we sure? Just make sure we're paying attention. Look, 360 minus 80. 280? Negative 280. Is it a big deal if you have the negative sign or the positive sign? Yeah. Make sure you got that, guys. How would I find... Let's do this one. Negative 135. Add 360 and subtract 360. What's my negative coterminal going to be? Negative 495. What's my positive going to be? What's 360 minus 135? $225. Good. Remember, when you're adding and subtracting, it's the angle plus 360, the angle minus. Don't put the 360 first. Angle plus, angle minus. Questions on that, guys? How do you find coterminals? Add and subtract what? Perfect. Okay, now we're going to talk. We're not going to get too deep into this. Yeah, I'm just introducing this to you. Some of you have seen the unit circle before. Some of you have not. You will become familiar with it once you get into your math class next year, whatever one you do. But one whole circle, you guys up in math have known forever, is 360 degrees, right? We are now going to talk about using that same circle, the same circle that we talked about, but the measurement is different. It's called a radian. 1 radian measure is 57.3 degrees. It's about 60 degrees. But 1 radian is 360 degrees. No, I don't know why I just said that. 1 radian is almost 60 degrees. It's 57.3. The radian, the unit circle is broken up into 6 like pieces. We'll talk about that in just a second. So if I look at this, here's my unit circle. This is normally 360, right? This is normally 90. This is normally 180. And this is 270. Those are all our degree measurements. I'm now going to introduce you guys to radian measurements. 1 whole circle is 2 pi. So what is half of a circle? 1 pi. Good. Well, what about if I cut that in half? It's pi over 2. So what would 270 be? Think about this. Let's think about this for a second. This is 1 pi over 2, correct? This is 2 pi over 2, isn't it? So what's down here? 3 pi over 2. And wouldn't you guys agree with me that 4 pi over 2 is the same as 2 pi? All you're doing is cutting 2 pi into quarters, to pieces. So 90 is the same as pi over 2. 180 is the same as pi, half a circle. 270 is 3 pi over 2. You guys need to be familiar with that. You don't need to be super familiar with it right now, but you need to understand. You're going to see it more in a little bit. What we're going to talk about right now is converting, changing from one to the other. There is a conversion factor. It's not, you guys don't have to sit here and be like, oh my gosh, you got to memorize. It's so confusing. It's not. You have to think about when you are converting something. If you're changing from one unit of measurement to another, you want something to cancel out, right? So the ratio you need to know is that 180 degrees is the same as pi radians and vice versa. 180 and pi go together. So when you are asked to convert, right, what am I starting off with? Degrees or radians? How do I know I'm starting in degrees? Somebody help me see how I could tell I'm starting off in degrees here. There's a degree symbol. Perfect. So I have 120 degrees. It's over 1. Well, think about it. If you're converting from degrees to something, then you want your degree measurements to do what? To cancel out or to stay there? We're going from degrees to radians. Whatever you want to cancel out, they should be on opposite sides. One should be in the numerator, one should be in the denominator. So am I going to put pi over 180 or 180 over pi? I'm going to say pi over 180. Do you see how we want the degrees to cancel out? If you have something on the numerator that's exactly the same as the denominator, what happens to them? They cancel. So if I have a degree in the numerator and a degree in the that is hard. Degree in the denominator, they cancel. Now, you guys aren't going to have a calculator, so I don't expect anybody in here to go, okay, 120 divided by 180, but we can do this slowly. What can I cross off right away? Can I divide both of these by 10? Okay. And now what number goes into both 12 and 18? 6, okay. 12 divided by 6 is 2. 18 divided by 6 is 3. So what am I left with in the numerator? 2 pi. And what am I left with in the denominator? 3. So 120 degrees is the same as... Sure, it's the same as 2 pi over 3 radians. So we're going to work on converting. We're going to work on canceling out. Whatever you want to cancel out, one should be on the top, one should be on the bottom. So if I look at something like this, are we starting off in degrees or are we starting off in radians? How do you know? I see a pi, and what do I not see? A degree sign. So guys, if I was going to ask you where this was on the unit circle or where this was on an XY, when I started on my initial side right here, what direction would I go? If I was going to draw it, which direction? Why would I go down? Because it's a negative. Very good. That negative stays with it, guys. It's no big deal. You just leave it. So I have negative pi over 12. And then my conversion, I have 180 in pi. Where does 180 go? Where does pi go? I want the pi's to cancel out. So where am I going to put the pi? On the bottom. Good. And where's the 180 go? In the numerator. Whatever you want to cancel out, one should be in the numerator, one should be in the denominator. So pi here cancels out with pi here. And now we simplify. I don't know the biggest number off the top of my head. Let's just start with 2. Does 2 go into 180? Yeah. 180 divided by 2 is how much? 90. 12 divided by 2 is what? 6. Does 2 go into that again? Yeah. 2 goes into 6 3 times. 2 goes into 90, 45. Does 3 go into 45? Yes. 3 goes into 3 once. 3 goes into 45 how many times? 15. So how many degrees is negative 5 pi over 12? How many? How many? Negative 15 degrees. The negative is super important because it tells us the direction. And then we have to have that little degree symbol. We okay? Oh, I kind of already talked about this. Sure. Again, you guys will get more familiar with this when we go to pre-cal or college algebra. You'll see it in both. But there's some very common measurements, like a 30, 60, 90. The common measurements, 30 is the same as pi over 6, 45 is the same as pi over 4, 60 is the same as pi over 3. Some classes you have to memorize the unit circle. It's just a pattern. Again, you don't have to worry about it right now. But just understand that one circle in degrees is 360 degrees, and in radians, it's 2 pi. Same exact amount. It's just a different way to measure. So let's talk about a few more conversions and then we're done. All right, what am I starting off in? What are we starting off in, guys? Degrees. And I want to go to then what? Radians. So where are the degrees? Where's the 180 going to go? So it cancels out. At the bottom. Perfect. 180 here, pi up here. First thing I do is cross off my degree sign. Because same thing on top and bottom. All right, so let's just simplify by 5. What's 135 divided by 5? 5 goes into 13 2 times. That's 10. 27. So this is 27. And then what's 180 divided by 5? 5 goes into 18 how many times? 5 goes into 18 how many times? How many times does 5 go into 18? 3. Good. So this is 3. So 36. Okay. Can I get that a little smaller? What number goes into both 27 and 36? 9. 3 does, but so does 9. Good if you see it. What's 27 divided by 9? 3. What's 36 divided by 9? 4. So 135 degrees, guys, is the same as 3 pi over 4. The hardest part of this is nothing that has to do with the pre-calculus and we're converting from degrees to radians. It's simplifying a fraction. There's 2 things in math, guys, that are never going away. It's going to be fractions and factoring. 2 favorite F words in math. All right, let's go through this quickly. Negative 40. Negative 40 what? Say it out loud. Negative 40 degrees. So I'm going from degrees to radians. Good. I want degrees to cancel out, so I have degrees on top, degrees on bottom. I'm going to go ahead and cross off my 0 and my degree sign. Makes my math a lot easier. What number goes into both 4 and 18? 2. This becomes negative 2. This becomes a 9. So negative 40 degrees is the same as what? Negative 2 pi over 9. Perfect. Scooting along. Ooh, what are we starting off in? We're starting in radians. I know what you meant. We're starting in radians. So what is my conversion going to be? Still pi over 180? No, the 180 goes on top now because I want the pi's to cancel out. Just got to be careful with that, guys. So look, pi here crosses off with pi here. Start with the smallest number possible. Does 2 go into 4? Yeah. Does 2 go into 180? 90? Okay. What about now? Can I simplify this a little more? 2 goes into 2 once. 2 goes into 90, 45. So I'm left with 45 times 5. Write it down. 5 times 5 is 25. Carry the 2. 225. So 5 pi over 4 is the same as 225 degrees. God bless you. One more and then I'll stop yapping. Oh, actually, don't worry about it. We're not going to get into that. Look, I'm done. Yay! Okay, so you guys have homework. It's not due tomorrow. I don't think it's due till Monday. Tomorrow we're going to start 9.3. I understand that it is a shortened day tomorrow, so we're going to start 9.3 tomorrow and finish it up on Monday.